Hi, I'm Sue Ryan, VP of Marketing for For All Systems, and we're here at CES 2025 to help people understand the importance of cooling in terms of maximizing performance in their devices, in their electronic devices. So there are basically two ways traditionally to cool a CPU or performance. One of those is passive cooling, so it's a heat sink, there's no active moving parts. The problem with that is it results in very bulky, heavy devices. The other way is active cooling, and active cooling can be has traditionally been fans, and those fans have disadvantages of their own. So if you put a fan in a device, number one, if you've ever lifted up your laptop, you'll notice there's holes across the bottom. So those holes need to be located right near the fan because the back pressure or the suction power of those fans are so weak, they have to have the holes right near to the fans themselves. Some other disadvantages of that are they suck in dust, and that over time degrades the performance. They're noisy, they're bulky. So there are a lot of problems with active cooling and passive cooling. So AirJet is a chip. It is a holistic heat removal device. So it eliminates the need for heat sinks, the big bulky heat sinks, or for fans. So the way this works differently is, as you can see, it's really thin. It's only 2.6 millimeters thick, 2.65 millimeters thick. It sucks air in through the top here, through these little filtered vents. It pulls the air in, and this has a suction or back pressure of 1750 pascals. So that's compared to 130 or 160 of a traditional laptop fan. So what that enables is you no longer need the intake air vents across the bottom of the device anymore, because that suction enables you to pull air and overcome the system resistance through really tight spaces. The other thing the back pressure does is it enables us to move air at a really, really fast pace across this tiny chip. So the air comes in and it moves down here in vertically impinging jets that impact on the copper spreader at the bottom of the chip inside it. That disrupts what's called the boundary layer, which are molecules of air which prevent the efficient transfer of heat into the air. Once those molecules are broken, that air can become completely saturated with heat, and then it's ejected out of the device through this vent here. So that's basically, and when I was talking about that back pressure, so this is an AirJet with 1750 pascals of back pressure. To get the same back pressure in a fan, you're going to be looking at a fan like this. And nobody wants a fan like this in their phone or their laptop. So we have two products at the moment. One is the AirJet Mini Slim, and that removes 5.25 watts of heat for a product, so it's very effective. And again, it's got automatic self-cleaning, built-in thermoception, which means it can actually measure the temperature and autonomously operate to maximize heat removal. So it's obviously smarter, a lot smarter than a fan or a heat sink, because it has that capability to adjust. And then there's the AirJet Mini Sport, which is our version of the chip that supports IP68 devices. So think action cameras, mobile phones, all of those things that people want to either take underwater, take in the snow, but they haven't been able to use active cooling because once water gets into a device with a fan, it obviously stops working. So they've always been constrained to passive, which is using heat sinks and dissipation through the skin of the device. So that is basically how it works.